so in this video we are looking at the perpendicular distance from a line to a point. So this is a new formula in the coordinate geometry of the line chapter in Leaving Cert higher level. So this formula is in your log tables, and let's just have a look at the formula now below. So the perpendicular distance from the point x1, y1 to the line ax plus by plus c. So our line needs to be in standard form. Okay, so it needs to be in this form. It can't be in y equals mx plus c. And what it just is the absolute value of a x1 plus b y1 plus c all over square root of a squared plus b squared. And that is it there. If you notice, we have modulus notation here. So we have modulus notation. The reason why we can't have modulus notation, absolute value notation, is because we're dealing with distance, okay? And we never really have negative value for distance. So another key thing to know about the perpendicular distance from a point to a line is the perpendicular distance is always the shortest distance. It's always the shortest path from the point to the line. It's always the shortest distance. So let's look at this question here. So find the perpendicular distance from the point 2 minus 3 to the line 3x minus 4y equals to 8. Now, this is a bit sneaky. They're little sneaky little snakes. This isn't in the correct form because the 8 is over here. So I need to move everything over to one side. Now it's in the correct form. So a is equal to 3, b is equal to minus 4, and c is equal to minus 8. And x1 is equal to 2, y1 is equal to minus 3. So let's sub everything in. So the absolute value of ax1, so it's going to be 3 times 2 plus minus 4 times minus 3 minus 8, or plus negative 8. Absolute value of that all over the square root of 2 squared. Sorry, not 2 squared, sorry. 3 squared plus minus 4 squared. So it's going to be the absolute value of 6 plus 12 minus 8 all over 3 squared is 9 minus 4 squared is 16. 9 plus 16 is 25, so all over root 25. So I'm going to have here 6 plus 12 minus 8 is the absolute value of 10 all over root 25, which is 5. That's going to be 10 over 5. And my answer is going to be 2. So my perpendicular distance from this point to this line is equal to 2. Another way we could be asked is we could be given the distance from a point to a line and we want to find the equation of said line. So the distance from 0, 0 to the line x plus y plus k equals 0 is 4 root 2. Find two possible values of k. So I know the perpendicular distance is 4 root 2 and the perpendicular distance is equal to, so a, b, c. So a is 1, b is 1, and c is k. So that is equal to the absolute value of 1 times 0 plus 1 times 0 plus k all over the square root of 1 squared plus 1 squared, because a is 1 and b is 1. So 4 root 2 is going to be equal to the absolute value of k on top all over root 2. Multiply both sides by root 2. I'm going to get 4 times 2, because root 2 times 2 is 2, is equal to the absolute value k. I'm going to get the absolute value k is equal to 8. 4 times 2 is 8. And the absolute value of k gives me 8. Therefore, k is going to be equal to plus or minus 8, right? Because the absolute value of minus 8 is equal to 8. And the absolute value of 8 is also equal to 8. So let's have a look at some exam questions now. So this is from 2004. The point minus 1 minus 5 is equidistant. So equal distance from the lines 3x minus 4y minus 2 and 3x minus 4y plus k equals 0, where k doesn't equal minus 2. So find the value of k. So I know the distance from this line to this line is equal the distance, sorry, from this point to this line is equal to the distance from this point to this line. So let's calculate the perpendicular distance. So that is going to be, so 3 times minus 1 plus minus 4 times minus 5 minus 2 all over the square root of 3 squared plus 4 squared, minus 4 squared I should say. The perpendicular distance is going to be equal to minus 3 plus 20 minus 2 all over root 25. That is going to be, so minus 3 plus 20 minus 2 is 15. 15 all over 5. Absolute value of 15 is 5. 15, absolute value of 15 is 15. 15 divided by 5 is 3. So the distance is equal to 3. Now that I know the distance is equal to 3, the distance from the point minus 1 minus 5 to this line should be equal to 3 as well. So 3 times minus 1 minus 4 times minus 5 plus k all over the absolute value of 3 squared plus minus 4 squared. That is going to be equal to the absolute value of minus 3 plus 20. That's going to be 17 plus k all over, well, we know at the bottom here it's going to be root 25, which is equal to 5. So therefore, I'm going to have 3 is equal to the absolute value of 17 plus k all over 5. Multiply both sides by 5. I'm going to get 15 is equal to the absolute value of 17 plus k. Now that I have an absolute value, I know is, I can split this up. 17 plus k is going to be equal to plus 15. Or 17 plus k is equal to minus 15. So k is going to be equal to minus 2. K is going to be equal to minus 32. Now, in the question here, it says where k does not equal minus 2. So therefore, that is not a solution. And my answer is k is equal to minus 32. Right, let's have a look at a more recent example now. So this comes from 2020. So the coordinates of 3 points are 2 minus 6, 6 minus 12, and minus 4, 3. Find the perpendicular distance from A to the line BC. So when we have notation like this, BC, it just means we're finding the line here. Based on your answer, what can you conclude about the relationship of these points? So let's find the line BC. So the line, I need a slope and a point. So my slope is equal to x1, y1, x2, y2. It's going to be 3 minus negative 12 all over minus 4 minus 6. This is going to be 15 all over minus 10. The answer here is going to be minus 3 over 2. So my slope is minus 3 over 2. And a point, it doesn't matter which one I'll pick. So I'll say my point is minus 4, 3. So I'll pick point C for this. So using my formula, y minus y1, so y minus 3 equals m, which is my slope, times x minus x1. Multiply across by 2 here. I'm going to get 2y minus 6 is equal to minus 3 times x plus 4, because minus by minus is a plus. I'm going to get 2y minus 6 equals minus 3x minus 12. Bring everything over to one side to get my equation of a line. I have 3x plus 2y minus 6, then bring it to minus 12 over, that becomes a plus 12. It's going to be a plus 6 is equal to 0. So, there's my equation of a line. Now I need to find the distance from A to BC. So, that is going to be the absolute value of 3 times 2. Plus 2 times minus 6 plus 6. All over the square root of 3 squared plus 2 squared. That is going to equal to the absolute value of 6 minus 12 plus 6 all over the square root of root 13. And then the top of my fraction is going to be equal to the absolute value of 0 all over root 13. And then 0 on a fraction just means my answer is 0. So the perpendicular distance from A to the line is 0. So therefore, the distance is 0. So what can we say? We can say A, B, and C are collinear. That means A is on the line BC. So here's B, here's C, bing, bing, jump, right? If A is on the line, therefore the distance is 0. So that makes sense. So we can say that they are collinear. Right, let's have a look at this example now. This is from 2021. So 2020, whoopsie daisy. So this is from 2021. The point P, ST, is on the line x minus 2y minus 8 equals 0. The point P is also distance of 1 unit from the line 4x plus 3y plus 6 equals 0. Find the value of S and the corresponding value of T. Hint, find S in terms of T. So first, what am I going to do is I know the perpendicular distance from this point to this line is equal to 1. So I'm going to do that first. So I know 1 is equal to the absolute value of, so 4 times S plus 3 times T plus 6 all over the square root of 4 squared plus 3 squared. That is going to be 4s plus 3t plus 6 all over 4 squared 16, 3 squared is 9, 16 plus 9 is root 25. Root 25 is equal to 5. Multiply across by 5 here. So 5 times 1 is 5. So 5 is equal to the absolute value of 4s plus 3t plus 6. So I can't really do much more here. So I have an equation of S and T, and I don't have any way of solving for either of them. But I do have a piece of information here. I know that this point is on this line. So using that information, I know if I sub in these 2 points here, this equation of line should satisfy, and that will give me an opportunity to rewrite S in terms of T. So I know S minus 2 times T minus 8 equals 0. S equals to, bring everything over to one side, 2t plus 8. Now that I have this information, I'm going to sub it back in here. So 5 equals the absolute value of, I know S is equal to this, so 4 times 2t plus 8 plus 3t plus 6. 5 is equal to the absolute value of 8t plus 32 plus 3t plus 6. 5 is equal to the absolute value of 11t plus 38. Now that I have one modulus on one side, what I can do is, so that's a 5, what I can do is I can say 11t plus 38 is going to be equal to plus 5, and 11t plus 38 is going to be equal to minus 5. So I have 11t is going to be equal to 5 minus 38, which is going to be minus 33. So t is going to be equal to minus 3. That's my first value of t. And then my second value of t is going to be 11t is going to be equal to minus 5 minus 35, which is going to be minus 43. So t is equal to minus 43 over 11. So I'm not done just yet, because it asked me to find the value of S and the corresponding values of T. So I have the values of T, so I need to sub them back in. So I'm going to sub them back into an equation to find a corresponding value of S. So I'm going to use this one here. So I know S is equal to 2 times T, so I'm going to use minus 3 plus 8. S is going to be equal to 2. So 2 minus 3 is my first solution here. My next solution, S is going to be equal to 2 times minus 43 over 11 plus 8 S will equal to 2 over 11 when you put that in your calculator. So the next solution is 211 and minus 43 over 11. And that is my second solution there. So that was a bit of a tricky one. It looks deceptively easy, but it goes on for a fair bit. Right, and finally, let's look at the 2012 question. So this question is from 2012, and the coordinates, 3 points A, B, and C are 2, 2, 6, minus 6, and minus 2, minus 3. Find the equation of AB. Easy enough. So I need my slope and a point. So my slope is y2 minus y1 all over x2 minus x1. And that is, so AB, so that is going to be minus 6 minus 2 all over 6 minus 2. So minus 8 over 4, which is minus 2. And then my point, I'm just going to choose one. I'm just going to choose 2, 2, right? So I could choose A or B there. So y minus y1 equals m times x minus x1. So y minus 2 equals minus 2 times x minus 2. Y minus 2 equals minus 2x plus 4, because minus 2 times minus 2 is plus 4. Bring everything over to one side. 2x plus y minus 6 equals 0. And that is my equation of a line there. So let's look at part B. So the line AB intersects the y-axis at D. Find the coordinates of D. So if it intersects the y-axis, the y-intercept happens at x equals 0. So this is when x is 0. So 2 times 0 plus y minus 6 equals 0. Y is going to equal to 6. So D is going to be equal to 0, 6. There is where it crosses the y-axis. Right, and then let's do part 3. So find the perpendicular distance from C to AB. So I have a point C here. C is minus 2, minus 3. I want to find the distance between that and the line. Easy peasy lemon squeezy. That's going to be 2 times minus 2 plus 1 times minus 3 minus 6. All over the square root of 2 squared plus 1 squared. So that gives me now minus 4 minus 3, which is minus 7. Minus 6 is going to be the absolute value of minus 13. All over the square root of 5. Absolute value of minus 13 is 13. Root 5 is equal to root 5. So that is my perpendicular distance there. Right, so the final part is hence find the area of the triangle ADC. So if we look back up here in this triangle here, so ADC. So I'm looking for this triangle right here. Now, you might be able to see it right away, right? But I'm able to use my formula half base by perpendicular height, right? So if I take DA to be my base, yeah, this here will be my perpendicular height. So, because it's my height that's perpendicular to our base. So if I find what DA is, I know what this is. This is my perpendicular distance. This is 13 over root 5. We got that from part C. So if I find what DA is here. So DA is equal to, so the distance between these 2 points, A is 2, 2. And then 0, 6. That's from part B. So it's going to be 0 minus 2 squared plus 6 minus 2 squared. DA is going to be equal to minus 2 squared plus 4 squared. 4 plus 16. DA is equal to root 20. So I have D is equal to root 20. I have my perpendicular height is equal to 13 over root 5. So a half times root 20 times 13 over root 5 should give me 13 units squared. When you put that into your calculator, you get 13 units squared is the area of that triangle. Right, so we still have another video left on perpendicular distance to lines. So this was just kind of using the formula. So in the next video, we're going to look at more applications of the formula as well. So I hope this video was some help to you guys, and I'll catch you guys later. Bye.